In this video, I'm going to use this example to illustrate the point why thinking about reverse system will actually help in your understanding, especially for the last part here. Now let's take a look at the question. You have a DC circuit, okay, and the EMF is 6 volt. The main current flows out here. When it comes to this point, the main current will split, okay, into two branches. In this branch, there are two identical 30 ohms resistors. They are connected in series, and in the other one 10 and 30 in series also, and then they join back. So from what you have learned, you know that the current flowing through this portion here will be the same, then it will split. Alright, so if you want to simplify the diagram, actually you can. So this will be, I combine the two 30 ohms resistor in series, so basically I just add them up and it's very simple math. That will be 60 ohms. Then for the other branch, okay, likewise the 10 and the 30 ohms resistors, they are in series, so I add them up, it will be 40 ohms. I can further simplify this to find the total effective resistance of the whole circuit. So the 60 ohms and 40 ohms, they are in parallel, so you just need to use the formula. So I'll guide you through. So the first part A, you are required to find the total effective resistance. So the finding both of them in series are already done here. So what you need to do is to combine the 60 ohms and 40 ohms together, and they are parallel. So recall 1 over RE equals to 1 over 60 plus 1 over 40, and using your calculator you'll get 1 over 24, but that's not the answer. I want RE, so you just need to invert back. So the total effective resistance of the circuit will be 24 ohms. In part B, you are required to find the current supplied by the current, and as mentioned earlier, from here the main branch all the way until here, the current is the same. So it basically you're looking for the main current, like the main river. So let's find I battery is equals to V over R. Okay, you'll be using V equals to IR, this formula that you memorize. So the V is 6 and you're using EMF, therefore you have to use the total effective resistance which you have found, which is 24. So the current will be 0.25 ampere. So that means throughout this section and through the battery, the current is 0.25 ampere, and the size, the magnitude of the current all depends on the total effective resistance. Likewise for here, 0.25 ampere, and throughout the whole circuit here, it will be 0.25. In part C, you're supposed to state why the potential difference across the point AB is 3 volt. Instead of finding, they ask you to state why. And as you know that in this branch, the two resistors are in series. So using the reverse system is like the height drop here plus the height drop here must be equals to 6 meters. And since they are both identical, okay, so each one will be a drop of height of 3 meter, 3 volt. So of course, you don't write about the reverse system, you should write about the rules of the resistor in series. So the sum of potential difference across the two resistors must be equals to the 6 volt. And since both resistors are identical, therefore the potential difference across AB, or rather each of them, will just be 3 volt. Next, in part B, you are required to find the potential difference across CD, which is this 2 points. Now there are two ways of solving. Let's go by the usual way, finding the current, after which we find the potential difference across CD. Now you understand that these two branches here, as long as they are parallel, the potential difference must be the same, and it happens that they are parallel to the EMF of 6 volt. That means to say the potential difference across each branch will just be 6.0 volt. So to find the current flowing through this branch over here, there will be I equals to V over R, which is 12 volt, and we look for the resistance, the total resistance in this branch, which is 10 ohms and 30 ohms in series, therefore total is 40 ohms. and you'll find that the current flowing through that branch will be 0.15 ampere. Next, once you know the current, and the current flowing through the whole branch will be the same, 0.15, because it's series. So next I find the potential difference across CD using V equals to IR. The current flowing through the 30 ohms resistor is 15 ampere times the resistance 30 ohms. Therefore, you'll get 4.5 volt. That's the answer. For the last part here, you're required to find the potential difference across point AC, which is this 2 points here. This is a bit unusual because usually you're finding the potential difference across a component, just like this fixed resistor here, and you put a voltmeter across. But over here, there's no wire linking these 2 points, but you are required to find the potential difference across them. So maybe now let's erase all this so it won't be so messy. Now, just recall the reverse system. Okay, to make things easier, let's recall that it's like a reverse system where this is 6 volt. So throughout this copper wire, there's no drop in the voltage, no drop in the height of the reverse. So this will be 6 meters, 6 volt. And just now previously, we found that the potential difference here is 4.5 volt. And that means to say, because 10 ohm resistor is in series with the 30 ohm resistor, so this has to be 1.5, because 1.5 plus 4.5, only then you will get 6. Okay, that's a series rule. So another thing you need to know is from the other end of the battery here, this is ground 0 volt throughout. Alright, so having said that, let's focus on this branch here. So in just like a reverse system, initially it starts from 6 meter, then there's a height drop, there's a height difference of 1.5. In other words, there will be a drop of height 1.5 meters or a voltage drop of 1.5. So after dropping, when it comes up from here, this will be 4.5 volt. And throughout this copper wire, this stretch, there's no drop in the voltage, no drop in the height. So throughout will be 4.5 volt. So, and that's why you have a potential difference of 4.5, because you take this minus 0, you will end up with 4.5. So we have settled for this branch. Let's go to the next branch here for point A. So just now we already said that this is 3 volt, potential difference 3 volt. That means to say before it enters into this resistor, the height is 6 volt. After a drop of potential difference, a drop in 3 volt or a drop in a height of 3 meters, when it comes out here, this will be 3 volt, and throughout this copper wire, the voltage is the same and the height of the reverse is the same. Then 3 volt minus away 0, that's why you have a potential difference of 3 volt here. So that means to say, in terms of reverse system, at point A, this height of the river throughout here, this height is 3 meters, and the other side, point C here, is 4.5 meters. Or in other words, at point C, this is 4.5 volt, and this point here is 3 volt. So if you were to put a voltmeter across point A and point C, you're measuring the potential difference, the voltage difference, or the height difference. So you take the higher voltage or higher height, 4.5 meters, minus away the 3 volt. Therefore, you have a potential difference of 1.5 volt across AC. So that's how you find it. So if you're able to see that the voltage drops is similar to like a reverse system, the height drop, you'll be able to visualize this and find the answer.